Hi and welcome into another video. In one of the previous ones, we were going through AWS console and getting the grasp on the application load balancer and target groups. So today we will build on that, but not through the AWS console, but through Terraform. So let's hop into our VS Code and work on that. Alright, so we are back in our Visual Studio Code and we are having our Terraform project, which we are creating in a few other videos. If you didn't see them, there is a Terraform playlist on this channel. But to go very briefly through that, we have a providers TF, which just instantiates a Terraform and AWS provider in US East 1 region, and our main TF consists of S3, which we will not use today, so let's just comment that out. And we have a VPC. So we are creating a VPC resource, then we are creating one public subnet, one private subnet. We are creating internet gateway for this VPC. We are creating a public route table for 0.0.0.0, so any IP going through internet gateway. Then we are associating this route table with a public subnet. Then we are creating NAT gateway in our public subnet to be used for the private one. We are creating elastic IP to associate with this NAT gateway. And then we are creating another route table for the private network and throwing all the traffic through the NAT gateway. Then we just creating another route table association now for the private one, and we are creating a basic security group which will allow access on HTTP port 80 for all the IPs. And then we were creating EC2 instance, but I will comment that out for now because we will create another one in the target group. So now, as we have all of those data here, we need to do some modifications. So first of all, what we would like to do today. Today we will create an application load balancer and we will create a target group and launch some EC2 instance in this target group on a Terraform loop, and then we will see if those instances are available through the ALB DNS name. But to do that, we need to do one modification. So in order to launch application load balancer, it needs to have 2 or more public subnets in different availability zones. So we will need to modify this public subnet to throw it into 2 public subnets. So we will do one, and we will need to create yet another resource for a public subnet second, and we will take a CIDR block of, let's say, 3, and this we will deploy it in US East 1B. So this will be a modification here so that we will be able to deploy this application load balancer, and we will need to change the some more stuff as we already modified it a little bit. So let's look for public subnet. So one more thing, we need to associate it with one more route table. So we will do subnet ID public subnet ID 1, and here we will add one more block of this association so that we associate it with the second one, and then NAT gateway will be deployed in a public subnet 1, and let's see if we modified everything. So here we have a public subnet 1, here we have a public subnet 2, here we have one association, second association, and NAT gateway deployed in public subnet 1. So that's okay for now. And now let's think about the application load balancer. So I already prepared the code beforehand so that you don't need to wait and see me type it. I will just copy that and we will go through it. So let's go here at the bottom. In some other videos, we'll make it more clear and make a modular approach to it. So we are declaring 3 new resources. One is a target group for our ALB. So this will be our AWS LB target group. We'll call it Nginx target group. We'll deploy it in our main VPC, and it will have a health check of a path on / and some health check settings and port 80. Other thing we'll deploy is application load balancer itself. So it will not be an internal one, it will be a public one. It will have a security group of this allow HTTP, and it will be associated with those 2 public subnets that we have. And then we will create a listener on it. So attach the listener to load balancer so that it will be aware of listening on port 80 HTTP, and then it will forward it to this target group. So now we need to think about the EC2 instances that we want to put in this target group. So I also prepared that. We'll copy and paste that and we will go through this code. So here we are declaring 2 new resources. One will be EC2 instance itself, and the second one will be registering this instance to the target group. So launch EC2 instance. We are just declaring as before, resource AWS instance, we will call it Nginx, and here we will do a count. We will also need to declare a variable for this server count. So let's declare it variable server count, and we can variable, I made a typo. Okay, so we are declaring variable server count, and wherever we will write here, this particular amount of servers will be launched using this count. And as you can see here, we are doing a very basic concatenation and we are choosing an element. So in fact, we are doing a modulo out of it. So depending on the index, if it's even or odd, we will be placing our instances either in a public subnet 1 or either in a public subnet 2. So let's maybe declare 4 servers. And then we will also use an user data script. We had a user data script also in our previous EC2 instance. And this user data script will be a script launched on the EC2 instance, and it will update the list of packages, install Nginx, take the instance ID from the EC2 metadata, take the public IP from the EC2 metadata, and instance number it will take from the count, and it will do this into Nginx HTML, index HTML, and we will have it written there. So we will be able to see that actually our load balancing is working. And then at the end, we are just starting this Nginx and enabling it. And here we are just attaching all of those EC2s created into our target group. So at the end, let's also do an output from our application load balancer mine ELB so that we have a DNS name without going to AWS console. So let's declare output, put ALB DNS name, the name of the ELB, and here we will get this ELB. So let's now launch it. All right, let's do Terraform apply. Okay, we did a mistake here. We somehow deleted that, and let's do it one more time. one more thing, consistency log. Let's do Terraform init. And now let's do Terraform apply. Okay, 24 resources to add. Let's launch all of that. VPC itself, Internet Gateway and Application Load Balancer will take some time to launch, so probably all of those operations will take more or less 5 to 8 minutes. So we will get back to it after everything is created. All right, and everything is deployed. It took more or less 5 minutes. As you can see, Application Load Balancer was the longest resource. It took 3 minutes to create. Okay, and we have our ALB DNS name here for our Application Load Balancer. So let's go into Chrome and let's just launch it. Okay, probably it will take some time for it to process. And yeah, we got some informations here. As we can see, we got an issue with taking the information from the metadata because we didn't approach the token. But we can see in our instance number that we change it from, it's changing from 1, then 3, then 0, 0, 1, 3, 2, 0, 1, 3, 2. As you can see, it is going through them one by one in the round robin style, which is the default one. So each consecutive request goes to another EC2 instance in the chain. So that will be more or less for today. And this is the approach to deploy the target group and application load balancer using Terraform. So that's all for today, and see ya next time.